In this video, we'll be discussing the purpose of secondary storage and explaining some of the common storage devices. So what is secondary storage? Secondary storage refers to non-volatile storage devices that are used to store data and programs permanently in a computer system. Secondary storage is necessary for computers because it provides a way to store data and programs permanently, even when the computer's turned off. This allows users to store programs and files for future use. When data is stored on a computer, it's stored on the storage media, which refers to the actual physical material on which the data is stored, such as NAND flash memory chips or magnetic tape. The storage drive refers to the physical hardware component that houses the storage media and provides mechanisms for reading from and writing to that media. Storage drives include hard disk drives, solid-state drives, and optical drives. Optical storage is a method of storing data using laser technology to read and write data on optical disks. These disks are made of a plastic substrate coated with a reflective layer, which is then covered by a protective layer. The data is stored on the disk in the form of pits and lands, which are tiny indentations and flat areas on the reflective layer. To write data onto an optical disc, a laser beam is focused onto the reflective layer of the disc. The heat generated by the laser melts the reflective layer, creating pits in the surface. These pits represent binary zeros and the lands represent binary ones. To read the data, another laser beam is directed onto the surface of the disk. The reflective layer reflects the laser differently depending on whether it encounters a pit or a land. A sensor detects these changes in reflection and then interprets them as binary data. Optical storage is great if you're looking for a more durable physical storage medium, as they're more resistant to scratches or fingerprints compared to the magnetic media like hard drives. They're also incredibly lightweight, compact and cheap, which makes them easy to transport, store and produce. They can also be manufactured as read-only mediums, which provides a secure way to distribute music, software and movies without the risk of modification. However, optical storage devices typically have lower storage capacities compared to the other storage mediums like hard drives and solid-state drives. Retrieving media from optical disks can also be much slower compared to other storage mediums, especially for random data access. Magnetic storage is the method of storing data using magnetic fields to magnetize particles on a magnetic medium. These particles represent binary data in the form of magnetic polarities. Magnetic storage devices include hard disk drives and magnetic tape. To write data onto a magnetic storage medium, such as the platters in a hard disk drive or the tape in a magnetic tape, an electromagnetic write head applies magnetic fields to the surface. These fields magnetize the particles, aligning them to represent the binary data being written. To read that data back, an electromagnetic read head detects the magnetic fields on the surface of the medium as it passes by. Changes in the magnetic polarity of these particles are interpreted as binary data, which is then processed and retrieved by the computer. Magnetic storage devices, especially hard disk drives, can offer large storage capacities, making them suitable for storing large amounts of data. They're also relatively low cost to manufacture, making them much more cost-effective per unit of storage compared to other storage technologies, such as solid-state drives. Magnetic storage media can also retain data for extended periods of time if properly maintained and stored, making them suitable for archival purposes. However, magnetic storage is not as durable as optical storage and can be vulnerable to damage from magnetic fields, physical shocks, and environmental factors like temperature and humidity. Retrieving data from magnetic storage devices can also be slower compared to solid-state drives, especially for random access data. Magnetic devices also have moving parts, such as spinning disks in hard drives, which can wear out over time and lead to data loss. Solid-state storage is a type of storage technology that uses electronic circuits, typically made of silicon-based semiconductor materials, to store and retrieve data. Unlike traditional magnetic storage devices such as hard disks, solid-state storage devices have no moving parts, relying solely on the movement of electrons within the semiconductor materials to store and access the data. Common examples of solid-state storage devices include solid-state drives, SSDs, USB flash drives, and memory cards. Solid-state storage devices store data by storing the electrical charges in memory cells within the semiconductor material. When data is written to the device, electrical charges are applied to the memory cells, altering their state to represent binary data. To retrieve data, the device reads the electrical charges stored in memory cells. This process involves detecting the presence or absence of charges to determine the binary data stored in each cell. Unlike hard drives, which rely on moving mechanical components to read and write data, solid-state storage devices access data electronically, resulting in faster read and write speeds. This results in faster boot times, quicker application loading times, and improved overall system responsiveness. They also have no moving parts, making them much less susceptible to mechanical failures and physical damage. This enhances their reliability and durability, leading to longer lifespans and reduced risk of data loss. Solid-state storage devices are typically smaller and lighter than hard drives, making them ideal for portable devices like laptops, tablets, and smartphones. However, solid-state storage devices have a limited number of read and erase cycles before they begin to degrade. While modern SSDs have improved drastically compared to earlier models, excessive write operations over time can lead to wear and the eventual failure of the storage cells. Solid-state storage devices also tend to be more expensive per gigabyte compared to HDDs. However, the cost gap has been narrowing as SSD prices have been decreasing over time. Although SSD storage capacities have been increasing, they still generally offer lower maximum storage capacities compared to HDDs. This may be a limitation for users requiring very high storage capacities at a lower cost. So, in this video, we've covered everything that you'll need to know about secondary storage for your exam. We've covered that secondary storage refers to non-volatile storage devices that are used to store data and programs permanently in a computer system and include devices such as hard drives, optical drives, and solid-state drives. So that's the end of this video. If you'd like to test your knowledge and access other lesson resources, make sure to head on over to revisio.uk